Okay, we're covering passage 3. This is a research passage. For our DRC approach, remember R stands for research and read. You're going to read, but not carefully, just skimming to get the basic idea of the differences between the studies or experiments. We know it's research because it says experiment 1, experiment 2, experiment 3. So I'm going to glance at this. We have a description of the experiment. Tells us what's happening. Looks like a ball is rolling down a platform and then it falls into sand. I guess Y is, where is Y? They tell us what they all are down here. Y is the height above the sandbox. That makes sense. So we have each of those labeled here if we need them. And the trials, looks like trial 1 through 5 at height, velocity, time, and X, whatever X is. Oh, X is the distance traveled. And then trial 6 through 10, what's different? Oh, hollow sphere versus a solid sphere. And experiment 3, the table height varied, the Y. And that's it. Now moving to the questions. For the R and R approach to understanding, you're going to read the question, skim through it quickly, then reread and break it down. We're going to do the reread together. Number 15, I think this is an easy, interesting question. Based on the results of experiment 1, so we have experiment 1, as h increased, so as the height that they roll the ball down the ramp goes up, did v, the velocity, decrease or increase? And we see that it increases also, so it's C or D. Now we have to know why, and this is where it's a little bit of knowledge and reasoning. The further up the ramp you go, the higher this height is, right? The more speed the ball will pick up and it'll be moving faster. So your answer is D. A little bit of knowledge reasoning there. Number 16, based on figure 1, in any trial, Y was. So what is Y? What does that represent? What does that stand for? And you may see it from the picture, or you may have to go to the reading, and it says the students placed a platform with a ramp at a height Y above a sandbox. So it's the distance between the sandbox and the platform, so J. Number 17, a control variable is a variable that is held constant throughout the experiment. ACT does not always tell you what that is, by the way. Some questions will say, what is the controlled variable? They won't define it. This one did. In which of the experiments, if any, is Y a controlled variable? And in our skimming, we saw that experiment 3, it was definitely not. They changed the height. So 3 is out. Then we go to experiment 1 and 2, tables 1 and 2. We see that the Y was set to a height of 95 centimeters. So it was controlled in experiments 1 and 2. So your answer is C. Based on the results of experiment 2, which of the following values of V and X, so velocity and distance traveled, I think is what X is, would most likely have been measured for the hollow sphere? So this is saying that what we see is correct, the hollow sphere, if it had been released from a height of 10. So 10 would be right here. So it's going to be between the variables of V and X. We have 2 columns, so let's just take them one at a time. The velocity is going to be between 77 and 133. So that has to be 105. And the X is going to be between 34 and 59. So it has to be 47. So your answer is F. Number 19 says consider a landing point. Remember, anything in italics is something you haven't seen in the passage. Landing point to be a point in the sandbox where the sphere landed based on the values of X, which is the distance traveled in trials 1 to 15. At the conclusion of the experiment, what is the greatest distance between the 2 landing points in the sandbox? This one takes a minute to think about, but what's the greatest distance between the shortest and longest? Just find the longest. Looking at all of them is 145, so you have to look at all the X columns in each experiment, and 145 is the longest. Which one's the shortest distance? 34. So what's the difference, right? The distance, the difference, 145 minus 34 is 111. So your answer is B. Consider the value of V, velocity, for a hollow sphere in trial 9. An object moving in a straight horizontal line with a speed would travel approximately what distance in 2 seconds? So it goes 203 centimeters in 1 second. So in 2 seconds, it'll be double that. So it will be 406 centimeters, or about 400 J. Number 21, maybe the hardest question so far in this test, just because it takes some thinking. Suppose, it means you have to think about the answer. They're not giving you everything. In trial 13, the speed, v, velocity, had been 171 centimeters a second. So instead of being 187, it was 171. Notice all the others are 187. And why is that? Because they're releasing the sphere from the same height every time. Based on the results, which of the following errors could have accounted for this result? So we're looking at experiments 2 and 3 also. There we go. So let's just break them down one at a time. The hollow sphere was accidentally tested. So we tested the solid sphere. The hollow sphere is experiment 2. And we see in experiment 2 that we do get the result of 171 from a height of 25, which would totally make sense. That's probably the answer. Let's go through and break down the others. The solid sphere was accidentally tested. Well, no, they were testing the solid sphere, and that, if they had tested, that's the result you would expect. So B is out. The height was accidentally set to 195. Well, if you're releasing it from a higher height, 195 instead of 25, the velocity would be much faster, not lower than 187, faster than 187. Or the height of y was accidentally set to 25. That wouldn't change it, because that's just the height of the platform. It would not impact velocity. So our answer is definitively A. You might have gotten that just going through them one at a time, and you get the answer in A and you move on, but you can break them down and think through it. This is a thinking question. Okay, reach out if you have any questions at all as you seek to understand this, and we'll end this one on a very silly joke that deals with physics. I was at a ball game the other day, and as the ball was hit and traveling towards me, I was trying to calculate about the arc and velocity and how long it would take to get to me, and then it hit me. Get it? Have a good day.